Okay, so let's go to the board. Why do I believe that I have a unique program? Why do I believe that? Because this is what I do, right? All right. I teach link thinking, boldness, and perseverance, right? When you have a problem, that's how you tackle it. Got to be bold, got to persevere, don't quit. Of course, you have to be logical, all right? Do analytical thinking. All right, so here's my challenge to students, though. I ask them, given the tools, would you be able to build a sound solution to a problem? I give you Solomon's guide. All right, so here, for example, I'm going to give you the tools, and then we are going to do today's puzzle. Like I said earlier, I teach math as puzzles. These are, okay, so these are the tools, and I need you to pay attention to it. If I have a number squared times another number, no, excuse me, times another number squared, we can put it together. Example, if we have 2 squared times 3 squared, we can say this is 2 times 3 all squared. Are you with me? So far, so good? Okay, can do more examples, Okay, now, if I take a square root of a number squared, I get back to the number. For instance, if I say square root of 3 squared, which 3 squared is 9. What is that? 3. So if I take square root of 3, I get back to 3. Square root of 3 squared, I get back to 3. Square root of 4 squared will be 4, right? You get that? Okay. All right. Let's get to this here. Prime factorization in exponent form. Okay. So we want to break the number 100 in prime numbers and then put in exponent form. So if I break it down, this is what I get, right? Okay, it's like a short notation. All right, so instead of writing 2 times, we use 2 squared, right? 2 squared, which is means 2 multiplied by itself, and then 5 squared, which is 5 times 5. Remember, 5 squared is not 5 times 2. Don't make that mistake. Okay, so you got prime factorization. So we break the 100 down. 100 is 10 times 10. 10 is not a prime number, so I keep on moving. And every time I get a prime number, I circle it until I have all prime numbers. Okay? All right. Okay. The fourth topic here. Are you with me? Stay with me. Stay with me. We're going to tackle this topic of identity, right? When the left-hand side of an equation equals right-hand side, identity. For instance, if I give you this expression here, 1 half x squared plus 1 half x plus 3 over 2, and I say it is equal to ax squared plus bx plus c, okay, for all values of x. If I say that I ask you to evaluate, and a, b, and c are constant, and if I ask you to evaluate this here, all right, that means I need you to find the values of a, b, and c, and then evaluate that expression. Okay, so now how do you do that? When you have something like this, right, where you have more than one letter in there and one line equation, this is identity. What I do is I compare like terms on the left side and right side. So the x squared term here and the x squared term here, I compare them. When I compare that, I see this a is the half, right? And then when I compare this here, we see that this b is also the half and this and c is the constant. So I know the values of a, b, and c, right? Now I have to do this operation, a plus b times c. Be careful, right? Be careful. If you do this first, you've made a mistake. You have to follow order of operation, PEMDAS. Okay, so now I've given you can pause the video, right? Maybe I'm moving fast. You can pause the video and okay, review it before you move on. So now you should get 5 over 4 if you do it right. Now that I've given you the tools, now I come here. This is what I do. I say now link it, recall previous skills, what you just learned. Be bold and logical, persevere, do not quit, right? Do not quit. So don't say I'm confused. Students say that a lot. Okay. They get in the middle, they don't know what to do. Just keep on pushing, right? Don't quit. There's an answer. So here is the problem. If 1,764 is equal to this expression on the right. 2 to the power A, 3 to the power B, 7 to the power C, where A, B, and C are constants. I say evaluate this. All right? Got it? And then part 2 question will be hence or otherwise, but without a calculator. Without a calculator, I want you to evaluate the square root of 1,764. Okay, what does Solomon's guide say? So it says use keywords, phrases, or features, right? To get a quick hint to what the problem is about. So I go to the problem right here. I've been given this number here, and it's equal to this. So if I look at it, 2, 3, and 7 are prime numbers. So basically, what this means is that it gives me a hint that this is prime factorization. So now I do the prime factorization of 1,764, right? When I do that, this is what I end up with. 2 times 2 times 3 times 3 times 7 times 7. So I'm going to put it in this exponent form. So 1,764 is this value here. But you remember in the question, we've been told is equal to this, right? Okay. So if we compare it, we realize that this A right here is the 2. This B is the 2. This C is a 2. Okay? All right. So now we know A is 2, B equals to C squared. So what is this here? What is this? Okay? If you get 8, you got it wrong. 8 is wrong, right? Order of operations, you got to do this first. 2 plus 2 times 2. Got to do this first. 4 plus 2, 6 is correct. 8 is wrong. Got it? Okay. So this could be your typical SAT question. Right? You could be in 5th grade, pre-algebra or algebra, but this is simple enough for you to break it down, right? But this will be a typical SAT question, right? Could be. The other part of it, the second part, to evaluate the square root of 1764 without a calculator, that's be like O level or A level math or IB. Okay, so now it says hence, right? That's a hint. Hence, evaluate, right? See that part right here? It says hence or otherwise, okay? But we've done most of it, most of the work. We know that 1,764 is 2 squared times 3 squared times 7 squared, right? And you remember what we did earlier? That if we have A squared times B squared, we can put it together and make it A times B all squared. So we rewrite this here, right? It becomes 2 times 3 times 7 all squared, which is equal to square root of 42 squared, right? You get that? And then you remember that if we take square root of a number squared, we get back to the number. So what do we add? 1764 is equal to square root of 42 squared. And so we get 42. Square root of 1,764 is 42. Get that? Math is so neat. Isn't that beautiful? Without a calculator, we've been able to use prime factorization to determine the square root of a number. So what do? Just link up with me, right? And if you do your part, I guarantee you I'll make you great or greater in mathematics. All right. So just connect with me here. All right. Smile fly, let's connect. We have once a week from the convenience of your home. Let's connect. Affordable too. The best and the most affordable. Okay? All right. Keep on practicing, and all things being equal, what do I keep telling you? You shall bloom. Welcome to Bloom Leadership Academy.